So we were discussing about laws of thermodynamics. In the previous first one, we discussed in the what you call in our second experiment we discussed about first law of thermodynamics, uh, and today we did that heat exchanger problem. Okay, and we just we were not able to do it in physical, but still I tried to explain how does heat exchanger work, what is two configuration, that is cross flow and parallel flow. Then we also shared, I also shared readings for that, and that is what was expected out of you to plot them and submit. Okay, and answer a few questions which was given in that in the manual itself. Now today we'll be talking about second law of thermodynamics. Okay, so why did we require second law? Anyone, why did we require second law?
To understand the direction of the process as well.
Right, Namya? Anything else you want to add? Anyone else who wants to add apart from the direction? Anything else? See, डायरेक्शन में तो कैसे ना कैसे चला ही.
Sir, to define
Sorry,
the first law.
define the first law.
No, sir, as in to complete the total cycle, that we have defined everything, but then again, we have to also, define that in the which direction the process is going on. So it could be the reason.
देखो direction is there, okay, but the thing is direction can be there, even maybe spontaneous direction may not be there, but आप किसी भी चीज को if you supply some energy then it can move in either direction, right? Spontaneity may not be there, but with external power agents we can move it in either direction. Okay, so important part is not just the direction but the quality of what you call the quality of energy, that is also which is something which is very very important. Okay, so that was defined, that was completed, that first law was completed using second law. Okay, because everything cannot be encompassed in first law, that is why we required second law. Okay, so these are the three laws. Okay, I want to go, ये हमने पिछले बार भी हमने किया ही था first law, so already aware. There were limitations of first law. It doesn't tell about the direction of the process. True. Okay, कौन से direction में जाएगा, that we are not aware. Okay, whether a process is feasible or not, that also cannot be told by first law of thermodynamics. Heat and work both are treated as energy forms, but you may understand, you should think that both are not interchangeable. कहीं पर अगर heat है, you cannot take it as electricity or you cannot take it as work, because 100% heat cannot be converted into work, right? There will be losses. Similarly, 100% of heat cannot be converted into electricity. Electricity के अंदर high efficiency is observed. Why? Because electrical efficiency is higher. Why? Because electricity is what you call high grade energy, whereas heat is low grade energy, right? Low grade को जब भी हम high, whenever we convert low grade energy into high grade energy, some external energy is required, external energy source is required. ठीक है? So that is what is told in the fourth point. It only deals with quantity of energy and not with quality of energy, whether it is high grade, it is low grade. Okay, then efficiency of completion of any process is also to be defined, and is not defined by first law, and it is to be defined. So for that we require second law of thermodynamics. So there are two statements of second law of thermodynamics. Can anyone tell me? भाई दिस इज वेरी बेसिक, आप लोग को पता होना चाहिए, 10-12 में भी पढ़ते हैं. व्हाट इज सेकंड लॉ ऑफ थर्मोडायनेमिक्स? दो स्टेटमेंट थे, उनके नाम बताइए, those two statements, and if possible give me the definition. किसी को भी नहीं पता पूरी क्लास में? मीट are you there?
Hello, sir. हाँ सर.
बताइए
sir,
सेकेंड लॉ ऑफ
एक second,
थर्मोडायनेमिक्स.
sir. Second law of thermodynamics. Heat cannot flow itself from cooler body to hotter body वाला sir.
हाँ, ये कौन सा है?
हाँ
There are
सर,
two
दो
statements, right?
स्टेटमेंट थे. हाँ, केल्विन प्लैंक और
कौन से?
दूसरा एक केल्विन प्लैंक था और एक क्लेशियर स्टेटमेंट.
Clausius, very good.
हाँ, क्लेशियर.
हाँ,
दो स्टेटमेंट थे.
याद नहीं आ रहा. Anyone who can tell me
हाँ,
about those
उनकी
statements?
definition
तरंग. मी तो कितनी जल्दी उसे तुरंत अनम्यूट किया, बच गया मैं. तरंग. तरंग.
एग्जैक्टली याद नहीं आ रहा है स्टेटमेंट. आई कैन नॉट रिमेम्बर द एग्जैक्ट स्टेटमेंट.
आई डोंट वांट एग्जैक्ट. कुछ भी तो बोलो. एग्जैक्ट तो मुझे भी पता नहीं होगा.
Sir, like it was like that there is no device which will convert like 100% of the energy, and there were like they were
It is impossible to construct a machine working on cycles that could convert heat into work with 100% efficiency or with single reservoir. That is somewhat ऐसे ही कुछ था, right? That was the first statement.
Yes, sir.
Second one was it is impossible to construct a machine, a device working on cycles that could transfer heat from lower temperature body to a high temperature body without any some external work. Okay, so that is what was the second law. इसके दो statements थे. Okay, so these are the two statements. It's on to your screen now. Kelvin Planck statement and Clausius statement. Kelvin Planck मैंने तो ऐसे याद किया था कि जो Kelvin Planck है that is related to heat and work, and जो Clausius statement is that is related to temperature. Okay, so Kelvin Planck's statement says it is impossible to for any device that operates on cycling to receive heat from single reservoir and produce net work. Okay, एक reservoir के साथ just to get heat and then convert it into work, that is not possible. There has to be some second reservoir in which rejected heat will be there. Some 70 to 80% will be converted, or 60% or 50% will be converted, or 20% will be converted into and rest will go to the sink. Okay, that is what Kelvin Planck statement says. Clausius, it is impossible to construct a device that operates in a cycle and produces no effect other than the transfer of heat from lower temperature body to a higher temperature body. Okay, that means कोई और effect का मतलब वही है कि they have to be some work input for that purpose. Okay, so second law specifies the direction, asserts on energy and quality along with quantity. वो सारे प्रॉब्लम्स जो फर्स्ट लॉ में थे वो सेकेंड लॉ ने हमारे खत्म किए. दैट इज वाई इट ऑल्सो पोज सम थियोरेटिकल लिमिट्स. ठीक है, द मैक्सिमम अमाउंट ऑफ एफिशिएंसी पॉसिबल फॉर हीट इंजन that is given by Carnot efficiency. Okay, Carnot efficiency is given by 1 minus T2 by T1, where T2 is the temperature of the lower temperature and T1 is the higher temperature. ठीक है, so T1 is the source temperature and T2 is the sink temperature. So if there is a heat engine, there is a heat coming from higher temperature body, ठीक है, and part of it is converted into work and part of it is rejected into sink. Okay, so this is what is done by so this is known as from the first law, from the second law it is coming. Similarly एक रेफ्रिजरेटर की बात करें, right? रेफ्रिजरेटर सेम कॉन्सेप्ट पे वर्क करता है, ओनली the arrow diagrams will change. Okay, you take the heat from lower temperature body and it is being supplied to higher temperature body. For this some input work is required. In this case we don't calculate the what you call the efficiency, we calculate the COP. Okay, we calculate COP of heat pump and COP of refrigerator. Heat pump is again higher temperature से नीचे आएगा, work done will be done and some heat will be rejected. अगर आप thermal efficiency heat engine की बात करें which is producing work, net efficiency is given by work output upon heat input. Heat input is coming from QH. Okay, so that is referred to as what you call the heat engine. But when there is last time, did I discuss about Hans Collard thing? Yes.
Yes,
Yes,
sir. I
sir.
remember you saying about hand collar device.
So anyone saw that
Yes, sir.
magnetoscope, Maparat, Mila kuch?
Yes, sir.
Were you able to were you able to find the blueprint?
Yes, sir. We were able to find it, but like as you said that it was not like it was correct, and there was some issues like with it. I
Actually,
read
Hans
many.
Collard was also very Hans Collard was also very intelligent. उसे पता था कि मेरी लाइफ को खतरा हो सकता है. What he did, he put some bug in it. There was some error in it, which is still not possible. So you all can try, right? Being ICT engineers, ऐसा क्या था भाई? Coil ही तो थे. Design was looking something like that. Okay, that is why when it was reproduced, the design was looking same, but there was some error which is still not able, we are not still able to identify, and many people are trying to develop that magnetoscope mapper. You can also try. I just gave you one food for thought and food for research. Okay, it is not a perpetual visual machine because there is some part played by gravity and some part played by magnets. Okay, so that is why it will not be a perpetual motion machine. Only thing is we are not calculating हमें सिर्फ heat and work ही energy दिखता है, but there are other sources of energy as well. It is utilizing those sources of energy for generation of power. Okay, so coming back to the point, so this is the second law for calculating the efficiency. This is how it is done. Work output upon heat input, 1 minus Q output upon Q input, and that is 1 minus T2 by T1. Okay, that is the efficiency. COP also can be calculated by the similar formula is different now. QL by QH minus QL, that is T2 by T1 minus T2, that is the formula. Okay, similarly for heat pump it is T1 by T1 minus T2. Okay, which is if you will do, you will find out the COP of heat pump. अगर आप करना चाहो you can do it. COP of heat pump will be equal to 1 plus COP of refrigerator. You can check it. I think I am right. Okay, so this is second law which I wanted to tell. Now how are we going to apply this, utilize this equation in the software? Okay, our what is the topic for today? I hope you all have that your manual available with you guys, right? Manual is there. I've already given during my first experiment itself. All the experiments manual is available with you guys. In the third experiment, what was the title of third experiment? Anyone can tell? The aim is to evaluate thermodynamic system using engineering equation solver EES software. Okay, and what could, why not go with this what you call, with EES software we'll try to solve this second law. Okay, we'll try to find out efficiency, and we'll try to find out the amount of heat while we'll try to initial temperatures are given. So suppose I have opened, I hope this EES is available, is visible. When you open EES it looks something like this. Yes or no बच्चों? Yes.
Yes, sir.
Yes, sir.
So I have so there is a question that has been given in your manual. The first question, case 1. Case 1 I'll help you to solve. Case 2 you have to solve by yourself. Okay. So case 1 was heat engine operates between a source at 500 degree centigrade and a sink at 25 degree centigrade. मैं ये वाला solve करूँगा. If heat is supplied to a heat engine at a steady rate of 1200 kilojoule per minute. Determine the maximum power output of this heat engine. Study the effect of temperature of the heat source and the heat sink on the power produced and the cycle thermal efficiency. Okay, let the source temperature vary from 300 to 1000 degree centigrade. Now we know that source temperature, ये second वाला part है, source temperature vary कर रहे हैं from 300 to 1000 degree centigrade. plot भी करना है. So there are 3 questions in all together given. तो पहला part is heat engine operate कर रहा है at 550 degree centigrade, that is T1 is 550, T2 is 25 degree centigrade. हमें ठीक है, the heat supplied, that is work done or heat supplied, is 1200 kilojoule per minute, right? Determine the maximum power output to the output of the heat engine. Now you can see, we know higher temperature is 550. We can put it in the equation format, directly type it. Next, lower temperature is 25 degree centigrade. Now Q supplied is 1200 kilojoule per minute, but we require Q dot, that is per unit time, per unit second, per second. Okay, so Q dot supplied is equals to 1200 by 60. Okay, so you will get somewhere around 20. Okay, 20 kilojoule per second. Thermal efficiency is given by 1 minus T2 by T1, that is TL by TH, both in kelvins. Kelvin में करने के लिए these temperatures are given in degree centigrade, so we have to add it at 273. Okay, I hope my cursor is visible. Here you can see lower temperature TL, which is 25 degree centigrade, plus 273 upon TH 250, 550 upon 550 plus 273. This is the thermal efficiency. Eta is given for efficiency. Okay, यहाँ पर हमें eta लिखेंगे. You can see the output कैसा आता है. Then work output. Okay, work output, that means per unit time, that is Q dot supplied into Q dot supplied कितनी की थी हमने 1200, that means 20 kilojoule per second into thermal efficiency, which we have calculated in the previous equation. So now you can see there are 6 equations, 6 variables. ये काम करेगा कि नहीं करेगा? What we'll do is we'll click on this arrow and see what happens. Once you check the equations, this type of message will be displayed. I hope those who are having, if you are using a system, you can carry out these equations by yourself. Right now itself you can carry out. You can write these 6 equations and you can see there are 6 equations, 6 variables, no syntax error. So once there is no syntax error, we can go with this. Next, you can click on calculate or solve button. Okay, once you click on solve, you'll get the answers. Thermal efficiency is 63%. That is the maximum amount of thermal efficiency that is possible. Okay, Q supplied is 20. Q dot supplied is 20. Automatically वहाँ पर हमने dot लिखा था, but यहाँ पर Q dot बन के आ रहा है. वहाँ पर हमने we wrote eta, but here eta symbol is coming. So this is the advantage of using that software. So all the values, you can see all the 6 variables are shown, plus it is also showing calculation time is fine. Okay, so thermal efficiency is required. So that was the first portion. Second portion was study the effect of temperature of the heat source and heat sink. Now we have variable heat source temperature and the sink temperature. Suppose we are varying the temperature from 300 to 1000 degree centigrade, and sink temperature for 0 degree centigrade, then for 25 degree centigrade, then for 50 degree centigrade. Okay, we have to calculate the thermal efficiency. Up right now we knew that we were putting this as single variable. Okay, but when we have to put it a multi-variable function, when we have to create it into a variable, we have to put it in curly braces. Okay, then only we will be able to make this table. So this is the input table that is required. We have to prepare this table. We have to get this answer. Okay, अब इसको कैसे करेंगे in EES, that is also given. So first of all, now we know this has to be changed into variables. So what we will do, we'll put curly braces here. Okay, both curly braces. Now अगर आप check करना चाहोगे, when you will check, there will be one error message which will be displayed, that is 4 equations 6 variables. इन दो variables के बारे में we have to put in information. अब इस information को हम कैसे डालेंगे? Since you have already seen we require a table, so there is a table option here. Okay, उस table में जाओगे, उस पर click करोगे. The moment you click, there is an option new parametric table. अभी हमारे पास और कोई ऑप्शन तो है नहीं, हमें नया ही बनानी है. So we'll click on new parametric table. This kind of parametric table will be there. अब you remember we require efficiency, we require work output. Another important thing is TL and TH. Okay, so यहाँ पर हमने क्या किया? We have to select which variables. So we wanted TH, TL, work output and efficiency, eta thermal. All those 4 we have added to the observation table. उसका नाम भी we have named it as, table name we have given as observation table 1. And we have to do 8 number of runs. यहाँ पर नहीं भी करोगे तो बाद में भी change कर सकते हो. Now we have come here. Now this will be the table which will be displayed. Okay, now you have to feed in the values. तो आप इस पे click करेंगे. The moment you click, this type of window will be displayed. Now you know you have to have 8 rows. 8 rows how? 300 to 1000, 300, 400, 500, 600 till 1000. Last is 300 to 1000. 8 rows. You just have to click on OK and that will be filled. Okay, TH values has been set. Similarly for TL also you can set the values. TL पे click करोगे, 8 values, all we have to set at 0. So you'll put 0 0 and you will get the values. And once you have done, TL is known, TH is known, you just have to click on this button, right? Solve button. The moment you click it, okay, the moment you click on that solve button, all the thermal efficiencies will be available. Work output will be available with respect to the source temperature. As you can see, as the source temperature is increasing, the thermal efficiency is also increasing. This is how we work. This is how first table is created. Now we have to do it for, you can repeat it same for 0 के बाद next table आप बना सकते हो. Next एक और table आपको बनानी है, right? For 25 degrees and for 50 degrees. Similarly, you can create 2 more tables, observation table 2, observation table 3. So that you can solve, you can do it by your own. Okay, now we have 3 tables ready. Now there was third, so that was the second option, and you can plot this table and use this for display in your manual. Now the last part was plot the power produced kilowatt hour and the cycle efficiency, that is percentage में, against the source temperature. अब भाई साहब ये plot कैसे करेंगे? Again a question has come, we have to plot it. Now we have that all those results are required. For 0 degree के लिए भी plot करना है, 25 के लिए भी करना है, 50 के लिए भी करना है. All those things are already there, right? Now tables have already been fed in. Now we'll go in plots. Plots के अंदर we'll go for new plot window and we need an XY plot. You select it. Once you select it, okay, this type of window will be displayed. Okay, so I have given step by step all the details. Now उसको आपको name देना है. You can give it as plot 1. Okay, इसके अंदर plot 1. Okay, observation table 1 के अंदर आप x axis पे क्या plot करना चाहते हो? You want to उसके अंदर लिखा है temperature versus work output. तो temperature, higher temperature and work output we are plotting against. If you want to what you call, want to plot it against efficiency with respect to temperature, that can also be done. ठीक है, आपको x axis में you can take temperature and on y axis you can take efficiency. It's up to you. Okay, if you want to name it, of course 8 है, वो सारी चीजें you can change if you want to change. If you don't want to change, you don't change. Okay, and you say okay. Once you click on OK, observation table 1 has to be selected. Once you say okay, this type of graph will come. Now this is work output with respect to TH. Okay, अभी plot 1 आया. अब मैं क्या चाहता हूँ, I want to put the values of observation table 2, that is with respect to temperature, that is base temperature TL is equals to 25 now for the second case. पहले वाले केस में TL is equals to 0, now TL is equals to 25. अगर नीचे का टेम्परेचर बढ़ रहा है, then what will be the effect? So what we'll do, कोई बात नहीं, now in plot section only we'll plot overlay plot. Okay, in plot में गए, now we require overlay. Since we have only plotted one, that is plot 1 we have plotted, so overlay का जो option जब आप click करोगे, the option will come only for plot 1. Set up overlay on plot 1. अब plot 1 में आप क्या plot करना चाहते हो? You want to plot again temperature with respect to work output, but this time the table will be different, that is table 2. Okay, so that changes you will make. टेबल 2 चेंज किया, मुझे TH versus work output we'll change it to observation table 2 and then we'll do it. Once you click on OK, you can see, and similarly you can do it for table 3. This is for table 2 when we have done, or table 3 we have plotted simultaneously. So plot 1 पे we have plotted an overlay of observation table 3. Okay, so 2 have been printed. Now again you want to do overlay, you can do again overlay and use table 3. Okay, सबसे पहले ये आना चाहिए था, table 2 का आ गया, पहले ये आना चाहिए था, then this would have come, and then now I am plotting for table 3. Sorry, the animation का order is misplaced. First, जैसे ही मैंने पिछली वाली slide खोली, whenever I did OK, as soon as I'll do OK, this will come. Okay, plot 1 will come with overlay. Now I want to add one more overlay, that is observation table 3. उसका मुझे overlay डालना है, तो we'll plot overlay plot table 3 and then we'll get this kind of a graph. This is what you have to show it. अब आप चाहते हो कि इनको लेबल कैसे करूं, मुझे लेबल भी करना है, राइट? इसका नाम दिखाई देगा तो मुझे पता है, अभी मुझे पता है क्योंकि I have plotted it. This one is for 0 degree centigrade, this one is for 25 degree centigrade, this is for 50 degree centigrade. But people should also be aware about it. So एक format text करके option आएगा, in that you can mention TL is equals to 0 और इसको दिखाना है हमें plain line से, right? So that can be done. Okay, and you will get this kind. Okay, again you want to put it, so again text डालिए, text पे click करिए, and you can add other text like TL is equals to 0 डाल दिया, similarly TL is equals to 25 इस तरीके से दिखाया हुआ है, so that you can put, and similarly all you can put the text over there. So this is what you will be plotting and showing in your text copy in your files. Okay, similarly that can be done. This is work output for temperature. Similarly you can plot thermal efficiency with respect to temperature for all the 3 values. First time करोगे तो time लगेगा, second time करोगे it will hardly take 10 minutes. Okay, this is how you can plot and you can show the results in your system or in your lab manual files. So I have done one question for you. I've already solved that and shown it in this entire slide. So I hope it is clear. अगर कोई बच्चा was doing it with me, I hope अब तक उसने first part तो over भी कर लिया होगा, first to second part. So this is all you have to do for your manuals. You have to plot those. So there are 2 questions in your manuals. I'm not sure if it is visible to you right now. Just give me 1 minute. So there were 2 cases. The first case ye, right? This one I have already solved in your what you call the presentation which I have shown. कैसे करना है, step by step I have done. Please follow the step correctly. If you will follow the steps correctly, you will be able to do it efficiently and nicely. ठीक है? One by one I am telling you again. आपने simply you will open your interface EES software. This was the question का first part. This is the entire question, but first part is still determine the power output of this heat engine. Okay, so simple, 6 variables, 6 equations. You will just solve, calculate, and first you will check whether all are in picture, all are there or not. Then you will just solve and you will get this result. Oh, abhi still your manual is being shared. Just a second. Okay, I hope now my presentation is visible, right? So similarly, you'll write this short program. It is already there in the presentation. You can put this short program. Just check whether all the things are satisfied or not. Just do the solve button. You'll get all the values. That is thermal efficiency and everything. You can put a screenshot of it. This is the first values that were required. Next one is you have to plot this table, because you have to plot it for 0 degrees, 25 degrees and 50 degrees. No, sorry, first you have to plot for 300 till 1000 degrees for all these values. तो पहले एक के लिए हम plot करेंगे for 0 that we have plotted. उसके लिए इन दो को the first two variables th and tl will convert it into variable form. After doing that, we'll insert table and propose the values which all variables are required in the tables. Once you have selected that, after that we'll put the values of th and tl. TL is first, it will be 0. th will vary it from 300 to 1000. Press OK. You'll get the entire table. Then we'll put the value of TL as equal to 0. Once doing that, we will just click on the button solve, and we'll get the entire value. This is the parametric table 1 for 0 degree centigrade. When TL is 100 degree centigrade, just a second. There's a parallel session going on, and I have to be moderator over there. So I'm just mentioning them. Just give me 1 minute, that I have a class right now. Okay, sorry for this gap. Actually, I had some parallel session, but no problem. First, I need to explain you guys. Okay, so I hope it is clear. Once you do this, after this, you once all the values are filled in, you can fill it for 25, you can fill it for 20, 50. You have to name the individual table as observation table 1 or table 1 directly, table 1, table 2 and table 3. And this will be important. Why? Because the last part, that is the plotting part, that will be utilized. Okay, so for plotting it, you'll go in plots, simple xy plot you'll do. Once the first plot is being plotted, then you will go for overlay plots. Okay, utilize this overlay plots. In this overlay plot option, you can go plot 1 के अंदर ही हमें plot करना है. Now the second time you will be plotting observation table 2. Okay, then once observation table 2 is plotted, then you again go in overlay plot. You will plot observation table number 3. Symbol is there, line is there, color of the line can be set here itself. Once you have got this, you can directly jump on adding text. When you add text, this type of text format text item will be available. You put the values TL0, उसको हमें कैसे दिखाना है, ऐसे दिखाना है. Okay, similarly blue वाले को हमने name किया है TL is equals to, say for example TL is equals to 25. For red one it is TL is equals to 50. We'll put all those values and finally we'll get this kind of a plot. This is the entire first plot which will be required, that is work output with respect to the higher temperature, that is TH. Second option will be plotting the thermal efficiency with respect to the temperature, that also can be plotted. Source temperature versus thermal efficiency, that will be printed. So this is how you'll do it. So this is the case 1 which I have solved. There is case 2. For an air conditioner you have to calculate the COP, right? Calculate the COP. COP का formula was given 1 दिया था ना? I hope you remember, students. It was given in the presentation itself. बाद में मत मैसेज कर करके पूछना. This is the COP. QL by W in. Okay. So W is the input work, input heat, input work, and QL is the lower temperature. QL को हम this is the formula which will come, QL upon QH minus QL. Okay, this can also be written in terms of temperature, that is TL upon TH minus TL. That will be the equation that will be used this time for calculation of COP for refrigerator. For heat pump it is QH upon WN, that is QH upon QH minus QL, that is T1 upon T1 minus TL. There is one more relation which I told you that you don't have to use in this, but you can calculate. You will get to know heat pump, COP of heat pump is equal to 1 plus COP of refrigerator. इसी equation को आप देख लेना. It will come in that way. Okay, it can come in that way, right? अगर if you subtract QL and add QL, so it will be 1 plus, so it will come as QL upon QH minus QL and 1. QH minus QL, that is 1. So it will come 1 plus COP of refrigerator, that can be calculated. So this is all you have to do. That is what you have to do for question number 2. Now please don't ask me again and again, sir ये कैसे होगा, sir ये क्या करना होगा इसके अंदर. It is very easy. All you have to do is utilize EES to solve this case 2 and of course case 1 also, right? दोनों के आप screenshots लगाएंगे of both of the table. The first part of the problem, that is efficiency. Second part of the problem is the table. The third part of the problem is the plot. Okay, for both these operations, for both these systems, you have to carry it out. So that will be submission for practical number 2. Okay, so this is all. I think I have explained enough. Any questions, students? Students, any question? I hope you can do it now. Just follow these steps correctly. Once you are done with the first question, first you do the first question, case 1. Once you finish that, then try to attempt case 2. Then I'm sure you will be able to do it. Okay, students, any questions? Anything you want to ask? I hope it is clear.
No,
Yes?
Yes,
No
sir.
clear? Not clear, Anupam?
Yes.
clear, but no question.
अच्छा, ठीक है. I'll share this PPT also in the Teams. Okay, experiment number 3 के अंदर, files के अंदर you will get this presentation. Okay, it will help you a lot. Okay, make sure अभी आपकी deadline खत्म हो चुकी है for experiment number 1. Okay, late turn-ins are only allowed. Okay, but they will be considered as late. Second experiment की भी deadline आने वाली है. Make sure you submit your second assignment before the deadline, before the last date, and then there will be deadline. Deadline के बाद तो आप submit ही नहीं कर सकते, right? Similarly, deadline for first experiment is coming. Maybe today is the deadline. You can please check. Okay, जिन्होंने भी नहीं किया है, please submit, but make sure it will be considered as late submission. Okay. Second assignment, of course, You have deadline till Sunday. You can finish it up, and then please submit. And then till then, I will be floating that experiment number 3rd as an assignment. That also you can do it. Okay. So this is all from my side. Since you have already said there are no questions, thank you very much. Anything you want to ask? One final last call.